And action. Hi, welcome everyone. This is the single channel wave rotor engine. I'm Calvin Lee with Keith Rivera, Alex Velazquez, and our advisor is Dr. Akbari. This project is the overview and summary of the single channel wave rotor engine. This brief overview will contain our work and progress done in developing the wave rotor engine, including some major project changes. Included will be our CAD work, drawings, and general analysis of the wave rotor engine. In the end, our overall objective is to take this unique concept from other models completed around the world to find room for improvement, build upon efficiency, learn, and therefore enhance as well as advance the knowledge of the wave rotor technology as a whole. We started off in weeks 1 through 6, finding a project that interested us, looking for ideas. We were balancing and juggling other ideas as well. Akbari did introduce a lot of projects that might have interested us. We did like one of them. And that was the IC engine of using the wave rotors as well. So week 6 to 10, we began researching it with research articles and research papers. It was kind of difficult because there's only 2 engines in the world that was made, one in China, one in Japan. So it was all based off of their papers and their pictures. Weeks 10 to 12, we started beginning the CAD while still reading those articles. Weeks 12 to 15, where we're finalizing our design and our CAD work, and we submitted our first report. Semester 2, we began finalizing everything and starting to 3D print. However, week 6 to 8, we ran into some big major problems. Of course, one of them is the pandemic. It had us sidelined and we couldn't really work on the 3D print. But also, we got a new design project with the standing wave reformers. They asked Akbari, and Akbari asked us to design a new engine that uses wave rotor technology, just like our other one, but however, instead of using internal combustion, it will be something else. Weeks 8 to 12, we made major design modifications accordingly to the new projects, and by weeks 12 to 15, we were presenting it. So the goal of this new project is to design a working single channel wave rotor engine. A wave rotor functions similarly to a turbo machine, such as a jet engine. A conventional compressor usually converts power into potential energy via pressured air. In a wave rotor, however, the central shaft uses wave rotors to exchange energy to 2 working fluids in direct contact with the use of shock waves. The intake and exhaust valves will be offset and will be rotating while enduring high and low pressure gradients, while simultaneously heat compressing the methane using shock waves that separated the methane gas. The purpose of this engine is to separate methane gas into hydrogen and pure carbon in a solid form. This project is in collaboration with the standing wave reformers.
Okay, so as mentioned earlier, the initial project design consisted of making a single channel rotary valve internal combustion engine. So as similar to the wave rotor engine that we're building right now, the single channel IC engine contained 2 rotating cylinders that created compression. It would also be able to create enough pressure to achieve combustion with fuel, air, and a spark. Right here you can see a full assembly of the final design of the IC engine. As you can see, we have 2 rotating valves. Everything else would be stationary. The 2 rotating valves would be rotating offset, and we can see on the left side of the valve, air would come in through that intake valve, and fuel will be injected, mixed, and ignited by a spark plug. In the back, you can see a combustion chamber, and on the right side, the exhaust gases would be purged through the exhaust valve. And yeah, these are basically just some different views of that final engine. There were some ISO side views, front views. Here are also some preliminary final designs of the intake and exhaust valves, and just some simple bearing holder drawings.
Okay, so here are some components from our new wave rotor engine that we had to design. So the difference between this one and the other one is the other engine was an IC engine. This one is using the technology of a wave rotor to thermal crack methane into, it's going from CH4 into pure carbon in its solid form, and then it's being broken as well into hydrogen. We still use the same single stationary channel. It's just that the purpose of the engine has changed now. And then here on the right side are the gas ports for the intake and exhaust of this engine. Each valve on this engine, as well as the end plates, have two ports, one for high pressure gas and one for low pressure gas. Here we have our exhaust end plate with gas ports, as I was talking about in the previous slide. The intake side of the end plate is very similar to the exhaust side. The only difference is that on the intake end plate and the intake valve are the degrees of separation between the ports. So for the intake end plate and the valve, the high pressure port is located from 0 degrees starting directly in the center of the valve and the end plate, and it goes from 0 degrees to 46 degrees. So if you're looking at the image of the valve, the intake is similar, it's just set up differently in the terms of degrees. So as I said, for the high pressure port, it starts from 0 to 46 degrees on the intake side, and then there is 71 degrees of difference between the high pressure port and the low pressure port. So the low pressure port starts from 117 degrees to 163 degrees, giving us 43 degrees of opening on that side. And the high pressure port I forgot to include was it's going to give us 46 degrees of opening on the intake side. For the exhaust side, which is depicted right here, the first opening that's the high pressure port, and that starts from 22 degrees to 71 degrees, and gives us a 49 degree variation in the opening. In between the two ports, there's 13 degrees of space in between. And the low pressure port starts at 84 degrees and ends at 129 degrees, giving us 45 degrees of variation. Here's our wave rotor assembly complete. This is the side view from the left. So basically this engine is powered by a motor which is connected to the shaft that runs down the middle of all the components in the assembly. The only spinning components, just like our IC depiction in the beginning that Calvin and Alex talked about, is that the only spinning components similar to the IC was the intake and exhaust valves. Everything else on this engine, just like the IC, is stationary. For this engine, the high pressure and low pressure gases are fed through the gas ports in the intake end plate and expelled through the exhaust end plate and ports. Once the gases are fed into the low pressure and the high pressure ports, methane is then introduced into this single channel, and it is compression heated using shock waves. Now, in order for this to take place, the reason that these valves are set at different degrees of opening is so that at some point in the rotation of the engine from the motor, there's going to be a point where both sides are going to be open, and then there's going to be a point where both sides end up closed, and this is where this compression heating induces a shock wave to crack methane. And then at some point, the exhaust is going to open up and expel, and then the whole process is going to be repeated. And like I said before, methane is going to be broken into pure carbon in its solid form and hydrogen. This is another view this is from the side view. So if you're looking at this from left to right, the left side is going to be the intake side with the intake port, which leads into the single stationary channel. And then, like I said, once both sides close, the process begins and occurs, and then it is expelled into the right side, which is the exhaust valve, and then that leads into the exhaust ports, and the process is then repeated. This is the front view. This is basically, so this assembly was separated. Basically in this assembly, or in this whole engine, we're supposed to have, everything is supposed to have tighter and closer tolerances. There isn't supposed to be this much separation in between the parts. It's supposed to be very tight and very close, like almost if the parts are rubbing against each other to ensure that there are no leaks. The only reason that we kept the separation is to show the different ports and all the different dimensions and angles that are given in this assembly. Other than that, it's the only thing that we're missing that we didn't include in this assembly was a motor, and we are missing bearings. So that way the shaft can rotate smoothly with the motor assembly. This is the back view of the engine. You can see that the ports are threaded, as well as if you go back to the other image, they're threaded to hold bolts so the end plate stays in place. And then this is our wave rotor engine operations, which I've already gone through and explained, but we presented it again in case you guys missed something and just need to overview how the engine works. But other than that, that's our whole presentation, and thank you guys.